Hello students, welcome to my Abhyas. My name is Sahana KS and I am your physics educator. So today we'll be looking into a session which is very important for you people, and it's very interesting chapter, and we call the name of that chapter as electricity. So when I just say electricity, you people normally can say every day we use this, right? We use this electricity or electric current in everyday life. So similarly, how is this electricity produced? So today's in this session, what we'll be studying is how did electricity come to existence, or was it there before itself, or how the scientists started discovering this electricity or the concept of electric current. After this, we'll be looking into electric current, how the physical meaning of electric current comes, that is in terms of physics, and then comes electric potential and potential difference. Electric potential and potential difference. So coming to the history, I hope we are a bit more interested in history, right? That how was electricity discovered? And I'll tell you, this chapter for your academics, it will be around 7 marks. It will give you around 7 marks, and this is completely useful for you in your second PUC if you are going with the physics, that is science. So coming to the history now. So what happened in ancient days, that is very long year ago, that is previous year you can say, there was a species which was called as electric fish, or you call it as electric catfish. So people, what would they do is, whenever they would catch this electric fish, they would have experienced some type of shocks, electric shocks. So they were very mesmerized, and also they had a question how this existed, how this electric fish has that type of power. So coming to this concept, after this, what happened was, this was actually given by Europeans. Okay, so Europeans were very humbled to see that electric fish has some type of thing which give us shock, which give human a shock. After that, what happened? Certain years, then Greeks, Romans, Arabians, they also started with this. And finally, they were discovering, after that they came to a conclusion that this electric fish species, whatever is there, it is there to protect other fishes. Because other fishes are easy prey for human when compared to electric fish. And then after the advancement, what happened was, this electric fish they used to treat some diseases. Okay, some diseases such as gouts. Okay, gouts is nothing but it is a bone disorder you can say. So they started to treat some ailments, some diseases like gouts. Whenever they would touch this electric fish, because of the shock, they would treat these gouts and also headaches. So then there was a stop. So there was a stop of what? The inventions. And then later on, what happened? After this electric fish concept, then came the lightning concept. So this lightning was none other than Benjamin Franklin. I think you people know what is lightning. So there is thunderstorm and lightning whenever it rains, right? So whenever it rains, whenever the two clouds come into contact, there is a huge lightning there. So that was given by Benjamin Franklin, and he was the first one who gave that this lightning consisted of electric current. So how did he do that? What did he do was, he took a kite, then he put a key to that. Okay. After that, he flew the kite whenever there was this lightning procedure happening. So when he put it, he observed shock in his hands. So as he observed shock in his hands, he knew particularly that there is something which is getting passed through us. There is some particle or something which is getting into us, and that is why we are having this type of electric shocks. So that was none other than, it was given by Benjamin Franklin, and then this gave the advancement for this electricity. After this, then there were numerous number of scientists, Ampere, Volt. Okay, so these scientists discovered electric current in one by one concept, and then later came Faraday, who again merged electric and magnetic concepts and then gave a new branch which was called as electromagnetism. So after this, what happened? So coming to the history, we got to know how the electric current was known to the people and to the mankind, and now in the modern society we are using this for the maximum level. That is, without electricity, without electric current, we are having nothing. Even now, whatever I'm teaching you, it's an online class, and this is nothing but it is because of the electricity advancement. So coming to the history, we have completed it. I hope this was very interesting for you. Next, moving on to the basic thing, which is electric current. So when I just go to the electric current concept, you have to just switch your brains to the chemistry topics. So what is that chemistry topic? You have to go to atom. Okay. So whenever I take an atom, what is an atom? It is a basic or a fundamental unit. Okay, in a matter. Fundamental unit in any matter is nothing but we take it as a atom. So why atom? We know how the structure of atom is. There is a nucleus. In the nucleus, we have subatomic particles which are called as neutrons and protons. And after that, we have electrons which are revolving around the atom. Moving on to the atom. So here, I said you before, this is a nucleus. If I consider, here you have proton and also here you have a neutron. So the proton is positively charged and neutron is neutral. After this, you have certain various shells. Okay, in this you have electrons which are revolving, right? So why I have to study this is, first thing, in 9th standard, you people have known what is a valence shell or a valence electron, right? So now if I take copper, whose electronic configuration is 29. So how can I just take it as, that is whose atomic number is 29, then the electronic mass, how can I take it? It will be 2, 8, 18 and 1, right? So that is 2 in the first shell, 8 in the second shell and 18 in the third one and last 1 in the last shell. So when I just take this and consider, say 2, 8 and 18, then at the last I have 1. So when I consider, so consider this as the last shell, that is the fourth shell, okay? So when I consider this, that time what happens, I have 1 electron here. As I have 1 electron, it's easy for me to take out that electron. How? By just raising the temperature or just giving some energy to it. This is very easy for me to take it out. So this shell which has valence or 1 electron, or you can say last electron, that we call it as a valence shell. Okay, and the electron which is there, we call it as a valence electron. Clear? So why I am doing this for you people is, here this valence electron is easy for me to just take it out. How? By giving some energy to it. So I give energy to that, when the electron is coming out, that becomes what? A free electron. So that becomes a free electron. Now just keep this free electron concept in your mind. What happens? There is a nucleus. Okay, consider a copper metal, and then the electronic configuration of that is 2, 8, 18 and 1. So if I consider copper atom, then here you will be having another 2 electron, that is electron shells. So here this atom will be there. Here you will be having 2 electrons, then here 8, 18 and then here you will be having 1 electron, which is the valence shell electron. And then that electron I can easily take it out by applying some external energy. Why cannot I take the electron which is inside? Because this will be the electron which is inside, that is in the first shell, will have a lot of influence of this nucleus. This nucleus, whatever is there, it influences this first, second, third shell, and it holds it very tight. So I have to give a lot of energy for that. But if it is in the last shell and if it is in the valence shell, I can easily remove it. So when I remove that shell, that is electron with certain energy, that time that electron becomes free electron. Free means what? There is no boundary, there is nothing. It can travel anywhere. Okay. So that type of electron I call it as free electron. So this you keep in mind, what is a free electron. Okay. Next, you have studied, that is, whenever you take any type of matter, okay, whenever you consider matter, that time what happens? You have two types of things, actually three types, but now I'll be only taking two types. One is conductor, that is, they are just taken in terms of two types, and then insulators. Right, I think you people have heard it, conductors and insulators. Generally what happens, whenever there is any type of electric repair or anything in your home or near your home or in that electric pole, that time these KEB people or electric power people, they come and then what do is they repair the pole using the rubber gloves. Why they use rubber gloves? Because the electric current shouldn't pass through them, right? That is what we call it as an insulator. Rubber is an insulator. What does it do? It doesn't allow the electric charges to pass through them. Okay. Then what about conductors? Conductors are the things, or the conductors are conductors which allow the electrons to pass through them easily. Okay. So how can it pass through them easily? For example, if I take, so these are some atoms in a material. Okay, one material is there, one matter is there. These are the atoms arrangement, and here I have the electrons arranged. Now what I do is, I put some energy, that time one electron comes out. As this one electron comes out, this becomes free electron, right? So this is the free electron, what I spoke. So free electron comes and it starts moving. Clear? So how, as it starts moving, then what happens? The electric current will be produced. So what is electric current? It is nothing but it is the flow of, or the rate of flow of charges. Which type of charges? Electrons. Clear? So the rate of the rate of flow of charges is called as electric current. And that is given by what? I is equal to Q by T. Okay, where Q is nothing but it is the electric charge and T is nothing but it is the time. So whenever in the definition, if you have this rate concept, that is the rate of flow, right? The rate of this, then it will be considered with time. So whenever you are doing the definitions, then you have to understand I is equal to Q by T, that is the rate of flow of charges. Okay, so that is electric current. I hope you people have understood. I just summarize once. So we have conductors, we have insulators. So conductors allow the electrons, that is conductors allow electricity to pass through them easily, right? Because we are also a type of conductors only. We what we do is we experience shock. So what is happening? The electrons are coming inside us. So conductors and insulators we have. Conductors are the things, or conductors are materials which allow the electricity to pass through them easily. But coming to the insulators, these are the materials which do not allow the electric current to pass through them easily. Why? Because conductors have free electrons. So whenever you have this energy given, the free electrons start roaming or start to flow. So whenever they start to flow, then there is nothing but electric current induced, right? Because the definition itself says the rate of flow of charges. So that is how conductors are. Insulators, there is no point of getting free electron. That is why what happens? They do not conduct the electricity, and that is why they do not pass the electric current to pass through them, because there is no one to take it and move, right? In conductors, electrons they just pass the electric current, but in insulators, they do not do that. Okay, so that is how it takes. So I is equal to Q by T is the expression for the electric current.